sklearn, model selection, group shuffle split. Description: Group shuffle split is a cross-validation iterator that groups samples by some group label. It is similar to shuffle split but ensures that all samples in the same group are in the same set. Either train or test. This is useful when you need to avoid data leakage between groups, such as in time series data or data with dependent samples. Inputs: N splits, the number of splits folds to generate. Test size, the proportion of data to include in the test split if float, or the absolute number of samples in the test set if int. Random state controls the shuffling applied to the data before applying the split. Pass an int for reproducible output across multiple function calls. Groups group labels for the data. Outputs: Train indices, the indices of the training set. Test indices, the indices of the test set. Steps: The data is grouped based on the provided group labels. The data is shuffled randomly. The data is split into train and test sets, ensuring that all samples within the same group belong to the same set. Metrics: Accuracy measures the percentage of correctly classified samples. Precision measures the proportion of correctly predicted positive samples out of all predicted positive samples. Recall measures the proportion of correctly predicted positive samples out of all actual positive samples. F1 score, a harmonic mean of precision and recall. Visualization plots. Confusion matrix, a visualization of the classification performance, showing the number of correctly and incorrectly classified samples for each class. ROC curve, a plot of the true positive rate against the false positive rate for different classification thresholds. Precision recall curve, a plot of precision against recall for different classification thresholds. Fine-tune parameters. N splits, the number of folds can be adjusted to control the number of times the data is split and the model is trained. Test size, the proportion of data used for testing can be adjusted to control the size of the test set. Random state, by setting random state to a specific integer, you can ensure reproducible results. Uncertainty methods. Confidence intervals measure the uncertainty in the estimated model parameters. Bootstrap aggregating bagging creates multiple models from bootstrap samples of the data to estimate the model's uncertainty. Challenges and fixes. Challenge 1: Uneven group sizes. If the group sizes are very uneven, it can lead to an imbalance in the train and test sets. Sample use case that resulted in challenge 1: a dataset with 10 groups, where one group has 1000 samples and the other 9 groups have only 100 samples each. Fixes to challenge 1: Consider using a stratified sampling technique to ensure that each group is represented in both the training and test sets in proportion to its size in the original dataset. You can achieve this by using the stratify parameter in the sklearn, model selection, group shuffle split function. Challenge 2: Limited data availability. If the dataset is small, the number of folds may be limited, which can affect the model's performance. Sample use case that resulted in challenge 2: a dataset with only 100 samples, split into 5 folds. Fixes to challenge 2: Consider using a smaller number of folds or a different cross-validation technique, such as leave one out cross-validation (LOOCV), which uses a single sample for testing and the remaining samples for training.